Welcome back to part 2 of our text adventure game example, the Red Dot Quest. We started off by looking at the design of the game, but now we're going to focus on actual development. In the agile metaphor that I gave in class, I talked about developing incrementally, but always having a final product ready to go. So our goal today is not to try and make a car or even just part of a car. Metaphorically, we want to try and build a skateboard. Now, a skateboard is not a car, but it still is basically usable. So we're going to try and make a game that is basically playable. Not really fun, not really able to do very much at all, but can let us run and type in something. Now, before we do anything else, let's give ourselves some authorship credit. So my name is Dr. Bart, and I am the author of this game. Now, looking through our classes, we have player, animal, and world. The world class is our workhorse. It is the main element of the engine. If we scroll down and look at our main function that was handed to us, we see that the world is the only thing that it actually knows about, and it uses various world methods. So our goal today is to implement enough of these world methods that we can actually play an iteration of our game, even if it's not very fun. So the first thing being called is the world constructor, which suggests that we should go implement our world constructor. And from there, we'll implement render start, whether or not the game, the isDone function, the isGood function, the render, the isInputGood, the process, the tick, and then render ending. So we'll start off with the init, and we'll actually do a bit of work here, because we know up front for free what are some of the fields that we need to give. The game's engine demands that the constructor not have any parameters other than self, which every method will always have. We don't have to provide any documentation because it's documented through the world class itself. So this will be pretty straightforward. We'll have one attribute for each of the attributes listed above. So we'll have one for game status. The initial playing status of the game is the string playing. The initial time is 0. At the start of the game, we're not encountering anyone, and we will have a player. Now, by calling player constructor, we're now obligated to go define the constructor for player. So we'll jump up and handle that next. If you're going to call the constructor, you've got to define init. And once again, we want to try and give no parameters for our player class. We don't need to pass in anything. It will only pass in self. Every player will have the exact same starting attributes. Now, when we do that, we have 4 attributes to set. We'll do self.location first. And if we check our design diagram, the starting location of the game is basically the home. So we'll set our home as being our starting location. All right. Let's see. Next up, we need to do the has catnip flag. At the start of the game, you do not have any catnip, and you cannot bark either. Now, the last thing we have here is a list of animals. In our game, the way we've designed things, this is a list, you start off with one animal, and that is Lady Ada herself. So we'll need to construct an animal, and animals will decide relatively arbitrarily. They will take in a parameter. They'll take in a name of the animal to represent themselves. So we'll have Lady Ada as one of our players. Sorry, one of our animals. Now, going down, since we've called the animal constructor, we're doing top-down design, we need to go and give the constructor for animals. As I said before, animals have a name, and that means we'll set a name attribute in reference to the name parameter. All animals start off with 5 energy, the maximum amount of energy that they can have. Now, I've written 5 here. That's kind of a magic number, and it might be better if I have something that represents max animal energy and assign that to be 5 and use that instead. And this way we'll consistently throughout the entire project be able to reference the maximum animal energy, even if we forget that it was set to 5, or maybe later on we decide we want to make it 6 or 10 or something more generous. If the player feedback from our testers suggests that napping too often gets boring, we could adjust it pretty easily. So we have some options. Now, at this point in time, I've created 3 methods. I've created my constructors for worlds, animals, and players. And it might be a good idea at this point to either try the game or at least start writing some assertions. So I can assert by creating some example worlds. So I create a world, and at that point in time, I would expect that I've called not just the world constructor, but the player constructor once and the animal constructor once. And I can assert a few things to verify that I've done this correctly. So I can assert that the time for the world is currently 0, and that the world's encounter starts off as none. I can also assert that the world players can bark is false, and similarly that they don't have catnip. And I can also even check that the world player.animals is a list of length 1. So various things I can do here. I could enhance that check even further, make sure make sure it's absolutely is an instance of a list using the is instance. And when I run it now, there are errors later in the code, so I expect the code to fail, but I can at least check out my assertions to make sure I've gotten all that stuff right. So it got past all my assertions, so that's great. It's working through all that stuff. In order to actually run the game, I need to give an initial win path and lose path, just a valid a valid value for these. So we'll slap in some square brackets, and we can actually make some progress and actually get the main function running. So we've moved the errors further down, and it's actually trying to play our game now. So we're getting actual error messages from from the running of our game. If we check out the line of code, it's our world is not good yet. But we have a few methods before we get there. At the very least, right now, we can feel pretty good about our constructors. That's progress. Now, let's go back up to our world and focus on the next method. At this point in time, we want to be able to have our game be able to play it at a very minimal level, not even necessarily any kind of interesting things, but we should be able to win or lose the game. So we have to write this isDone function. IsDone is a method. It consumes nothing and produces something. So determines if the game is over or not. Now this is a pretty straightforward one. If we're writing it, it produces a Boolean indicating whether or not the game is over. If it's true, then the game should end, otherwise it's not. There are various criteria you could set aside for whether or not your game should be over. The most obvious one at this point in time is just whether or not the game status is not playing. Because once we set it to win, or to won, or lost, or quit, the game ends. But as long as it's playing, we're still going. So this is a pretty simplistic start. Now we have an opportunity with our isGood method. So the isGood method is meant strictly for development purposes. Its goal is to help you sanity check your world instance. So determines if the world state is valid right now. And that means it uses the world state, doesn't consume anything, but it produces a Boolean indicating whether the world is valid. You could do any number of things. You could check to make sure, for instance, that the world's game status is a string. And if it is, then you return true. If it isn't, it returns false. And this will help you catch errors where the game status has gotten out of control. You can make this very sophisticated. So right now I'm just checking whether or not the game status is a string, but I could also check to make sure that the game status is in the set of playing, won, lost, or quit. So now I'm using my list membership operator to test if the given string for game status is in my list of known valid states of the game. And I could add more and more sophisticated tests in here, making sure that time is a number, that time is greater than or equal to 0, and so on and so on. But this is for debugging purposes. We don't necessarily need to worry about it too much this early on. You might just have it return true, and that's all it does right now is just return true. So it's up to you how you want to use it. I'll leave in my check to make sure my game status is valid, but I'll build on it later as I'm debugging my game. Okay, so we've moved further along. We have our game, we have our constructor. We have the test to see if the world is done. We have whether our game is good. We have a bunch of render methods. And at this point in time, we're not doing anything fancy with our renders. So we'll just have our renders. They're functions that produce strings. They consume nothing. Render creates a string representing the current state of the world. Then similarly for render ending and render start, they creates a string representing the final state of the world and the initial state of the world. And all of them also returns a string, the message to display to the user. So we'll copy this again and get these for free. It's okay if they're more or less the same as each other. They're very simplistic methods. As I said before, they've got to return something. They've got to produce something, but they don't have to produce anything at all, which is just, so let's just make them return simple strings of just, the current world. Doesn't even have anything sophisticated there. Remember, we're just building a simple skateboard, not a bicycle, not a motorcycle, not even a car, just a simple skateboard. So for the ending, we'll return the end. Actually, the end. And just to be slightly more sophisticated, we'll also print out the game status, which is a string, so it's valid to add it to a string literal to end up with the end : game status. Okay, great. So, and then we'll do render start, and for there we'll just say the title of the game, red.quest by Dr. Bart. Very basic. Okay, so now we've made even more progress. We have our world. We have our constructors, we have our renders, we have our is done, is good, and the last thing we really have to do is check for valid input. This is the only other thing we really have to do. Before we launch into that, let's do a few more assertions just to make sure the stuff we're writing is good. We've written is done and is good, so let's see if is done works just a little bit. At the start of the game should not be done. So assert that the world is not done. Assert that the world is good. That should definitely be the case. And we can assert that our print statements are producing what we expect. So if we render the initial state of the world, render start, we can expect the red.quest by Dr. Bart. And if we assert the render function itself, we can expect that it would print out the string literal, the current world. And I say print, but I'm being cavalier. The engine prints on our behalf. You see that there's a print down there. That's why we have render start producing strings. It doesn't print. We make it print for us. So I can safely type check and safely assert that the result is this, as you'd expect. We're not going to call the render end just yet. We're not going to test out that function. We'll build up to that, because next up we still have to do our process is input good and tick. But let's take an opportunity to run our assertions, make sure we're doing well. Ooh, we're actually making progress enough now that we can play more of the game. It's printing stuff out, and it's waiting for user input. So we passed all of our assertions. That's good. Let's go up, and we'll go, and we need to put in something for is input good. And at this point in time, we'll accept literally any input. Just anything that is typed in will be acceptable in our game. But that doesn't mean we'll respond to every possible input. We can instead do something at least a little bit intelligent. Actually, no. Let's do any error checking in here. We'll stand by the theme of the engine, which is the idea that the given input, so the given input should be validated here, and then we will assume that when we get to the process phase that the thing given is a valid command. We won't do any more sophisticated error checking beyond what happens in isInputGood. Now both isInputGood and process are methods that consume commands, so some user input. So we'll need to update our parameters for process, take in a command, and same thing with isInputGood. And we'll write some doc strings for them. Tests if the given command is valid for the current state. And this actually has args, so we'll type in command as a string, the user's given command, and the return is a boolean indicating whether or not the command is acceptable. Process also has a parameter. It doesn't produce anything though. It doesn't need to produce anything. Updates the world state based on the command. Pretty straightforward. And it doesn't produce anything, could print, doesn't matter if it does or not. And tick doesn't consume anything either. It just passes the time. So we have to go determine if the user's input is good. For our very basic skateboard level kind of game, we're going to only accept 3 different strings. We'll accept win, lose, and quit. So we will literally test if the command is in win, lose, or quit. And if it is, we accept it. Otherwise, we will continually prompt the user for input. On the process side, if the command is equal to win, pretty self-explanatory, we set the game status to be win, 1, past tense. And if the command is lose, we will set the game status to be equal to lost. And finally, you guessed it, if someone types in quit, we will set the game status to be equal to quit. And in theory, this is all we need in order to run our game. We can leave tick to just be a no-op right now. We should probably give it a bit of documentation. Tick is a method that updates the world state after one round. So this is used for things like updating time or weather effects, whatever we want it to be. It doesn't consume anything, doesn't produce anything. It's up to us how we use it. Your game might not even use it. Perfectly reasonable. And just to round out our unit tests, we'll assert, we'll process some user input. We can assert that if the user is input good, if the user tries to type in something like gibberish, then it will not be good. But if the user types in something that is good, like win, I should say, win, then that is good. And we can process the world and tick the world and assert that the world is now done. So the world is now done, and we can also assert that the ending is achieved, assuming we did everything correctly. Render ending produces the end : 1. And we can try it out. Maybe I made a typo, maybe I didn't. I did make a typo. My process command is supposed to take in the actual user input. Forgot to do that. Easily done. And it passed all my assertions, and now it's actually having me play the game. So I can type in win, and I won the game. If I type in lose, I lost the game. And if I type in gobbledygook, it keeps prompting me until I type in something valid. So right here, right now, I have produced a game. I can give it a win and a lose path. And in theory, you know, I've met a lot of the technical requirements of the game. I've made a product that I could actually hand in and get some large portion of points. Not large, but some portion of points. It's not a very fun game, it's not a very sophisticated game, but it's certainly a valid game. So this is a good starting point, and in the next phase we can add to it and make a bit more exciting stuff.